Hello everyone, welcome back. Here's Van Amsen. Today we have fascinating task to tackle together. We will be exploring a unique problem called minimum speed to arrive on time. Where we will be embarking on a journey, taking multiple trains to reach the office. And our goal is to determine the minimum speed the trains need to travel for us to arrive on time. So if you love challenges that involves optimizing routes, and time management, this one is just for you. So, all right, let's understand the problem statement. We have floating point number hour, which represent the total amount of time we have to reach the office. And to commute, we must take n trains in sequential order. So we are also given an integer array dist of length n, where dist I describes the distance in kilometer of the each train ride. So now here is the catch. Each train can only depart at an integer hour, meaning we may need to wait in between each train. And our ultimate goal is to find the minimum positive integer speed in kilometer per hour that all the train must travel at for us to reach the office on time. So if it's impossible to reach the office on time, the function should return -1. So to solve this intriguing problem, we will implement it in C++. So let's implement, and then I will tell you whole implementation. So int n dist size, and if n -1 greater than hour -1 less than 0, we return -1 because we cannot reach. And then we initialize two pointer for our binary search. So 1 and max element distance begin and distance and int sale of distance. So it's maximal possible pointer on the right, and while left less than right, int midpoint will be left plus right minus left divided by 2, and double total time will be 0, and for I 0, I less than n -1 increment and total time plus sail distance divided by mid, and total time plus double dist n -1 divided by mid. And if total time less than hour, then right will be mid, else left will equals mid plus 1. And finally, we return left pointer. Okay, so let's run to verify everything work for this given test case. Okay, so everything's work. Awesome. So before we delve into the main logic, the code starts by performing input validation check. It first determines the number of trains writes n. So the number of trains that write n by ascending and assessing the size of this vector. So if there are no train writes, so for example, it's less than 0. So for example, 0 or something, or only one train. So n equals 1. Or if the number of train writes -1 is greater than the given hour, or if the difference between hour and n-1 is less than or equal 0, the function return in every this case -1, indicating that it's impossible to reach the office on time due to logic constraints. So now comes the heart of the solution, so the binary search algorithm, and the code set up a binary search to find minimum speed needed to reach the office on time. So the search space is initially set between the left pointer of 1 and right, where right is computed as maximum of the maximum element in dist and speed needed for the last train to reach on time. So the binary search iterates until left is less than right, and at each iteration it calculates the mid value as the average of left and right. So this value represents a potential speed for the train. So next, it calculates the total time required to complete the journey at the current mid speed. So it does this by looping through the first n minus train rides and adding the times taken to complete each ride. And the time taken for each ride is calculated as the sailing of the distance divided by the mid speed, because we can start only on full hours. So this ensures that we account for potential waiting time between trains. And finally, it adds the time taken for the last train ride to the total time. And if the total time is less than or equal to the given hour, it means we can reach the office on time with the current mid speed. So in that case, we set right equals mid, effectively reducing the search space for the next iteration. And if the total time exceeds the given hour, it means we cannot reach the office on time with the current mid speed. So we set left mid plus 1, narrowing down the search space for the next iteration. So, and there we have it. We successfully analyzed and explained the provided task, minimum speed to arrive on time. So let's run it for unseen test cases as well. So yeah, it's working, and our implementation beat 93% with respect to runtime and 25 with respect to memory. So all good. And yeah, I hope you enjoyed this adventure in coding and learned something valuable technique along the way. And now it's your turn. Try implementing this algorithm in your favorite programming languages, or experiment with different test cases to deepen on your understanding of this problem. And happy coding, keep practicing, keep exploring, and see you next time.